My name is Dr. Jedidah Isler. I'm an observational astrophysicist by training and Chief Science Officer at the Federation of American Scientists. FAS is a nonpartisan science and technology policy organization dedicated to using science, technology, and innovation to improve the lives of the American people and strengthen the nation. That mission is not new to us. FAS was founded by scientists who understood through World War II and the dawn of the atomic age that scientific discovery could become world-shaping technology faster than our ability of our democratic institutions to govern. That founding insight remains true today. The bills before this committee cover a wide set of technology, from robotics, immersive technology, semiconductors, open source and open weight artificial intelligence, quantum engineering, biotechnology, memory chips, and connected and autonomous vehicles. These technologies and the bills under consideration differ in design, scope, and market maturity, but they share a simple premise. American leadership in critical technologies is valuable, vulnerable, and worth protecting. I agree with that premise, but my core message today is that technology leadership is not self-executing. It's not a subscription service that renews automatically. It's more like a garden that must be cultivated over time. The technologies we want to see, the chips, the AI models, the biofoundries, are the harvest and not the seed. But the harvest depends on the soil. That soil is technically trained people who animate our basic and user-inspired research. It is standards, test beds, commercialization pathways, and manufacturing capacity. And it is the federal government capable of moving at the speed of technology. At FAS, we approach technology competitiveness from this science-first perspective because science underlies technology. Technology is what science becomes when knowledge is translated into tools, products, systems, and capabilities. The United States cannot lead in the technologies of the future while neglecting the scientific enterprise, and most critically, the people that produce them. That's why a hearing on American technology competitiveness must also be a hearing about American science, talent, and government capacity. America's scientific leadership has always been a people's story. The United States became the world's science and technology superpower precisely because it built institutions capable of training, attracting, and empowering extraordinary talent, including Robert Oppenheimer, Carl Sagan, and Katherine Johnson, just to name three. Generations of students, technologists, engineers, researchers, program managers, entrepreneurs, and skilled workers turned public investment into discovery and discovery into public benefit. Some of these people were trained in American public schools, community colleges, universities, and national laboratories. Many came from around the world because the United States offered something rare, an opportunity for open inquiry, world-class institutions, and freedom to pursue ambitious ideas. Training more Americans in STEM and attracting the world's best scientists and engineers are not competing strategies. They are mutually reinforcing requirements for American technology leadership. You can't decide one year and then employ technology and technologists the next. It takes on average 8 years after a bachelor's degree to arrive at technical expertise in many fields. When we lose that talent, we lose capacity that cannot be replaced on short notice. In a world of technology leadership, it's more than who sells the final product. It's about who trains the workforce, owns the equipment, who sets the standards, who controls the supply chain, and who can translate discovery into deployment effectively. That brings me to the legislation before the committee, which I'm happy to engage with individually during the Q&A. Congress should evaluate whether each of these bills, not only by the technology domain it names, but whether it strengthens the underlying system that allows the United States to lead in that domain. A commission, a study, procurement guidelines can be useful if they're producing actionable recommendations and follow-through. All could be bolstered by adequately resourcing the full R&D development life cycle. Congress has shown it can act deeply and impactfully in bipartisan ways with CHIPS and Science, ARPA-H, and a variety of other bipartisan legislations. Our next step is to make those pieces durable, implementable, and connected to research and workforce base. Thank you, and I look forward to your questions.
Thank you so very much. Now,